Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Physics Pen. Most of the time, mathematics is used to explain physics or to derive physics. But this time, I'm going to use physics to derive and explain mathematics. And obviously, what better example do I have than solving a problem? So in today's problem, we have two particles. Let us call them particle 1 and particle 2. You can also color code them. Well, actually, I am color coding particle 1 with red color and particle 2 with green color. Keep it in mind that I am going to use the same color code throughout the video. Now, both of these particles are moving with constant velocities v1 and v2 along two mutually perpendicular straight lines towards the intersection point O. Initially, the particles were located at the distances L1 and L2 from point O. Now we have to find the time it will take for the distance between these two particles to become smallest, and what will be that smallest distance. Now, using Pythagoras theorem, we can derive the initial distance between these two particles in terms of L1 and L2. With all this knowledge about situation, we can form an equation for the distance between these two particles as a function of time. For that, we can have an imaginary time t, in which particle 1 has moved L1 prime distance from its initial position, which will obviously equals to the product of its velocity v1 and time t. So the remaining distance L1 double prime can be written as follows. And the same will happen for particle 2, except for 1 will be replaced with 2 in all of the measurements and equations. Now, the new distance between these two particles will have L1 double prime and L2 double prime in place of L1 and L2, which then can be replaced with what we found in equation 2 and equation 3. Keep it in mind that we have to find the time at which the distance between both of these particles will be smallest. We can clearly see that L1 and L2 are constants since they represent initial distance of the particles from point O, and so are v1 and v2 as already given. So the only variable the distance between these two particles depends upon is t. So to find the value of t at a minimum value of h, we will differentiate the fourth equation. So let's do it. So on the left hand side we have h squared, which can be said to be the function of a function of t. You don't get it? So let me explain it the different way. Suppose we have a function z, which happen to be the function of y, and y is the function of x, and we have to find d by dx of z. So to do that, we will find d by dy of z, and then we will multiply it with d by dx of y. In this case, we have h squared in place of z, h in place of y, and t in place of x. And this is what we will have in the left-hand side of the equation. Now, same thing we will follow on the right-hand side of the equation for both of the terms. And now, before proceeding further, let us learn some maths. And in this section of the video, we are going to learn the concept of extrema. And if you already know it, you can always click here. When you throw a ball in upwards direction, the value of height will change according to this equation. If you remember my previous videos, you can clearly see the only variable here height depends upon is time. Now, if we plot a graph with height on y-axis and time on x-axis, we will get a graph looking something like this. And if you have to point out the maximum height and the time at which it was achieved, I think you can easily do it like this. And that point on the curve is known as the maximum extrema, or the maxima of the curve. And at that point, the differential of the equation for the curve is 0. Just like velocity is the differential of height and is 0 at the highest point of the ball's flight. And also, the double differential have a negative value at this point. just like acceleration is double differential of height and is having a negative value since displacement, or height in this case, is increasing in upwards direction and acceleration caused by gravity is in downwards direction. Now if you let the ball go a little further in downwards direction and let it fall into water below your level, which is 0 on y-axis, obviously it will experience some buoyant force causing an acceleration in upwards direction, which will eventually result into zero velocity of the ball in downwards direction if the ball have a lesser density than that of water. And that point is called the minimum extrema or minima of the curve. So you can clearly see here that the direction of acceleration is the only difference between minima and maxima. Or you can also say in terms of mathematics that the sign of double differential is opposite in both the cases. So we can conclude this part of the video by saying that the differential of the equation responsible for the curve is 0 at maxima and minima, and the double differential is negative at maxima and positive at minima. This mathematical property of curves can be used to find the minima and maxima without drawing curves. And that is what we are going to use for solving the problem we are dealing with. So if you are still curious and you want to draw the curve, you can take the primary equation and plot the curve between h and t for some value of L1, L2, V1 and V2. Or you can always go to this website if you're a lazy slob like me. I've already given the links in the description because maybe you are a lazy slob like me. You will notice that there is only one extrema of the curve, which in reality is the minima of the curve. Well, if you are a smart lazy slob, you don't even need to do that. If you look into the situation carefully, you will notice that there is only one point of time when both of these objects are closest to each other. But the maximum distance between these two objects may expand to infinity. And that point of time may be this, or even this. So you only need to differentiate, put its value equal to 0, and solve it for the value of t. Well, actually this is to save time, but if you have enough time, you can always double differentiate the equation and put the value of t you found in the previous process. And if you get a positive value for that, which you will, I would like you to know that you have got the value of t for minimum value of h. Now the only job left for us is to find the minimum value of h, which we can easily do by putting the value of t in the primary equation which we formed. That is the fourth equation. So this is what we are looking for, and this is how we solve the problems related to extrema. Thanks for watching, and don't forget to like, share and subscribe.